your knowledge of, and subscribe to our channel and click the bell icon for the latest update. So here we go for it. In physics, talking about for class 11th, yes, we had done your physics part 1, where we had completed your unit 1. The unit 1 which we had discussed about, it is about physical world. Unit 2 which we had discussed about units and measurement. Now we're gonna start with your unit 3rd, and that will be your motion in a straight line, that we even though had discussed in the last classes. So we'll continue with the same. Unit 3rd is motion in a straight line, that we have to discuss here. So here we go for the same. Here in the same we had discussed some of the numericals, that is being important one, and now we'll continue with the numerical only. Here we had completed your last as your 4 questions of the session, but before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and you can also enjoy the video as well. Now here we go for the question, and that we have as follows. The question 5th of this unit is free fall. It is all about free fall. So free fall, you have to discuss the motion of an object under the free fall, neglect air resistance. So we go for it. This is the question is for free fall. The question is discuss the motion of an object under free fall, neglect air resistance. So that we have here. So the question here, for then an object that released near the surface of the earth is accelerated downward under the influence of the force of the or gravity. The magnitude of acceleration due to the gravity is represented by g, and if air resistance is neglected, the object is said to be in a free fall if the height through which the object falls is small compared to the earth radius g, that can be taken to be the constant equal to 9.8 meters second inverse square. Free fall is thus a case of motion with uniform acceleration. We assume that the motion is in y direction, more correctly in y direction, and that because we choose upward direction as positive, since the acceleration due to the gravity is always downward, and it is in the negative direction, and we have here that is being like a equals to minus g, which is equals to minus 9.8 meter second inverse square. So the object is released from rest at y equals to 0, therefore v naught is equals to 0, and the equation of the motion that becomes v equals to 0 minus gt, which is equals to minus 9.8 t meter second inverse here. Y equals to 0 minus half gt square equals to minus 4.9 t square meter. V square equals to 0 minus 2 gy equals to minus 19.6 y meter square second inverse square. So here This equation gives the velocity and the distance traveled by as a function of time, and also the variations of velocity with distance. So the variation of acceleration, velocity and a distance with time have been plotted, and for will be plotted like this, and that you will be able to understood as well. So this is 0, for this it is will be 1, and this is 2 here in t seconds, -5, -10. From the upwards it is a meter second square. So here -10, for that it is above -10, that is 9.8 meter per second square. So on this way further, which we'll be discussing in a detailed about it. So we'll be having another graph on it, and that will be drawing, of course. So which will be have as follows. So we'll be just making a graph here. The motion of an object under the free fall, the first will be having your variations of acceleration with time. So I just write it on so that you will be clear to it. This is motion of an object under free fall. So this one is your for variation of acceleration with time. Okay, now we talk for that second one which we have here, and that what we'll even though have to talk about it in the detail. So here we go. So the second graph we have is been as follows. This is 1, 2, 3, 4 and 5. This is of t of seconds. 0. This is -10, -20, -30, -40 and -50 meter per second. So it will go from here to here. Okay, that's what it will go. This is the variation motion of an object under the free fall, variation of velocity with time. Variation of velocity with time. Now we go for the another graph. It will be like this. 1, 2, 3 and 4. This is 40 times second. Here it is 0. So this is -10, -20, -30, -40, -50, -60, -70, -80, -90. So this is for variation of distance with time. Now we go for another question that we have is the 6th question of the session. So the question we have, Galileo's laws of odd numbers. This is the question has been dependent, and that the question is the distance traveled during equal intervals of time by a body falling from rest stand to one another in a same ratio as the odd numbers beginning with unity, that is namely 1:3, 5:7, till that you have to prove it. So let's go for it, and that what we'll have to Here we have to prove all of them, so we go for it. The question is, this question is from Galileo law of odd numbers. The question is, the distance traversed during equal intervals of time by a body falling from rest stand to one another in the same ratio as the odd numbers. Beginning with unity, namely 1:3, ratio 5, ratio 7. You have to prove it. So for the same, let us divide the time interval of the motion of an object under the free fall into many equal intervals, which is that, and find out the distance here. And on the same way to it travels during the successive intervals of time, and since initial velocity is 0, so we have here y equals to minus half gt square. We are using this equation, we can calculate the positions of the object after the different time intervals, that is 0, tau, 2t, 3 tau, and that which are in the second column. I will discuss that. And if we take half, minus half g tau square, and that is as y naught. So the position coordinate after the first time interval tau. Then the third column gives the position in the unit of y naught, and the fourth column gives the distance traversed in the successive tau seconds. So we find that the distance are in the simple ratio 1:3, ratio 5, ratio 7, ratio 9, ratio 11 as shown. We'll discuss that. And this law of to be established by Galileo Galilei in 1564 to 1642 was the first to make the quantitative studies of free fall. So let's go for it. Just make a table here first. So for that it will be about t, then we have y, then y in terms of y naught equals to minus half gt square. Then we have distance traversed in successive intervals, and this is for ratio of distance traveled. Now we find it out here. So here we go for it, and that will be having s. So here we go for that. It will be, first we have your 0, t is equals to 0, y equals to 0, this is equals to 0, and that has been there. So for the same here, so with the same here, this is tau minus 1 by 2 gt square, this is y naught 1, this is 2 tau minus 4 1 by 2 gt cube, gt square only, so 4 y naught 3 y naught, and this is 3. Another is 3 tau here, which is minus 9 1 by 2 gt square, so 9 y naught 5 y naught 5, 4 tau minus 16 1 by 2 gt square, 16 y naught 7 y naught, and this is 7. This is 5 tau minus 25 1 by 2 gt square, 25 y naught 9 y naught, and 9. Another is 6 tau minus 36 1 by 2 gt square, this is 36 y naught 11 y naught, and 11. This is how it will be made. And for the same, this law was established, I just write it on for you, so that if it has been written, so you will be get to know, and you just write it on as well, because what I had explained is only for that time, then when you are gone through with the video. So just write it out. If you have made the notes, you will be able to understand. So this law was established by Galilei from 1564 to 1642, who was the first to make quantitative studies of free fall. Okay, now we go for the another question that we have here, as being the 7th question of the session, so that we talk about it. It is, the question has been all about stopping distance of vehicle, so we go for it. So stopping distance of vehicles that we discussed here. The question is, when brakes are applied to a moving vehicle, the distance is traveled because stopping is called a stopping distance. It is an important factor for road safety and depends on the initial velocity, which is v0, and braking capacity of deceleration minus a, that is caused by the braking, and derive an expression for stopping distance of a velocity in terms of v0 and a. So I will go for it. Here we go. The question is, when brakes are applied to a moving vehicle, the distance it travels before stopping is called stopping distance. It is an important factor for road safety and depends on initial velocity, V naught, and the braking capacity or declaration minus A that is caused by the braking. Derive an expression for stopping distance of a vehicle in terms of V naught and A. So let's go for the solution here. So for that, let us distance traveled by a vehicle before it stops be ds, and then using the equation for v2 v square equals to v naught square plus 2ax. Okay, so for that it will be noting that v equals to 0 at having a stopping distances. So here ds equals to minus v naught square upon 2a. So thus the stopping distances is proportional to the square of the initial velocity, and doubling the initial velocity increase the stopping distance by a factor of 4 for the same deceleration. For the car of a particular make, the braking distance was found to be 10 meter, 20 meter, 34 meter and 50 meter, corresponding to the velocities of 11, 15, 20 and 25 meter per second, which are nearly consistent with the above formula. And stopping the distance is an important factor that considered in setting speed limits, for example in the school zone. So here we go for the another question that has been the 8th question of the session. So I just tell you about, and that we'll discuss in the next coming class because that will be exceeded more. And the question we have here for the reaction time: when a situation demands our immediate action, it takes some time before they really respond, and the reaction time is the time of a person that takes to observe, think and act. For example, if a person is driving and suddenly a boy appears on the road, then the time elapsed before he slams the brakes of the car in the reaction time, and the reaction time depends on complexity of the situation and on an individual. You can measure your reaction time by a simple experiment. Take a ruler and ask your friend to drop vertically through the gap between your thumb and forefinger, and after you catch it, find the distance d traveled by the ruler. And it is particular case in a particular case d was the found to be 21 centimeter. You have to estimate the reactions as well. You have to measuring the reaction time here. So we do that, and we'll be dealing with the same question. So we go for it, and first we'll do that. So the question we have for reaction time, and the question is, when a situation demands our immediate action, it takes some time before we really respond. Reaction time is the time a person takes to observe, think, and act. For example, if a person is driving and suddenly a boy appears on the road, then the time elapsed before thus before he slams the brake of the car is the reaction time. Reaction time depends on complexity of the situation and on an individual. You can measure your reaction time by a simple experiment. Take a ruler and ask your friend, take a ruler here and ask your friend to drop, and ask your friend to drop it vertically through the gap between your thumb and forefinger. After you catch it, find the distance d traveled by the ruler. In a particular case, D was found to be 21 centimeter. Estimate reaction time. So this is a long question, of course, but we'll solve that. So here this is a concept that if this is a ruler, you will just, your friend is holding this from upside and downward from you, that is measuring the reaction time here. So for the same here, that we'll find out the ruler that drops under the free fall. So there we will be having V naught is equals to 0 and A equals to minus G, which is equals to minus 9.8 meter second inverse square, and the distance traveled D and the reaction time TR are related to it, and where D equals to minus half GT square, or TR equals to under 2D upon GS. So here given that D equals to 21 centimeter and G equals to 9.8 meter second inverse square. So the reaction time is being TR, which is equals to under root 2 into 0.21 upon 9.8. We'll get the answer 0.2 seconds. So this is the question all about that what we'll have to cover up, and now we'll be continuing with the next class, that has been the another topic which will be your relative velocity in the 23rd class of the session. So here we're gonna end up with. Thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Other than this physics, we had done your chemistry part 1, chemistry part 2 for class 11. We are dealing with the quantitative aptitude, where we had started with arithmetical ability. In that we had done your 16th topic. We'll be surely starting with the 17th topic as well. And we had done your reasoning, which is your verbal reasoning and the non-verbal reasoning. Even though we had started down your CBNST, we are dealing with the DBMS. And coming towards physics for class 11 for part 1, we had done your chapter 1, which is your physical world. That's what is physics, scope and excitement of physics, physics, technology and society, fundamental forces in nature, nature of the physical law. The unit 2 is your units and measurement, which we have to cover up about introduction, the international systems of unit, measurement of length, measurement of mass, measurement of time, accuracy, precision in instrument and errors of measurement, significant figures, dimensions of physical quantities, dimensions of formulas in the dimensional equation, and dimensional analysis and its application. Unit 3 is a motion in a straight line, which we had started with. Introduction, position, path, length and displacement, average velocity and average speed, instantaneous velocity and speed, acceleration, kinematics, equation for uniformly accelerated motion, and then we'll discuss about the relative velocity, and then we'll end it up. Unit 4, which we have to cover up, is your motion in a plane. Then unit 5 is laws of motion. Unit 6 is work, energy and power. Unit 7 is a system of particles and rotational motion, and unit 8 is your gravitation. That's what we have to cover up. So here we're going to end up with. Thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you.